Hello, welcome back to another tutorial. Today we are going to learn our final exponent rule, and that is the negative exponent rule. So how this rule works is if we have a number or a variable to the power of a negative exponent, what we can do is put a 1 divided by the positive version of this exponent. So a to the power of negative n would be 1 divided by a to the power of positive n. So, for example, if we have b to the power of negative 2, that would be the same as 1 divided by b to the power of positive 2. The reason why this rule works is when we are talking about exponents, normally an exponent would tell us how many times we multiply a certain number or variable. But if we have a negative exponent, that's the opposite of a positive exponent. So if normally it tells us how many times we multiply a certain number, if now we have the opposite, it tells us the opposite thing. So instead of multiplying, the opposite is dividing. So a negative exponent tells us how many times we divide a certain number or exponent. So here we are dividing this many times the b. We're dividing the b 2 times. Here are a couple longer examples. So the first one, a times b to the power of negative 4. So when we have exponents, we need to think about them separately. This a is separate from the b. So the a is just an a to the power of an invisible 1. The b, however, is to the power of negative 4. So with our negative exponent rule, what this tells us is that we could change this b to the power of 4 to be 1 over b to the power of positive 4. We could simplify this a little bit more and put it all together as one fraction. So we're multiplying this a times the fraction. So if I'm multiplying, I can make this a fraction as well, and do a times 1 is a, divided by 1 times b to the power of 4 is b to the power of 4. So this is the final simplified answer. The next example, x to the power of 3 times y to the power of negative 4 divided by z to the power of 2. So here's a little trick for you. When we are working with exponents, the most simplified possible answer has no negative exponents. So if you have a negative exponent, you need to make it a positive exponent in order to simplify your expression. So the x and the z are already positive, so they're already simplified. But this y is negative, so we need to make it positive to make it simplified. So my trick for you is all you're doing, so notice how when we have b to the power of negative 4, if we put a 1 on the bottom, that wouldn't change the value. And this equals 1 to the power of 1 divided by b to the power of 4. Notice how all we did is we switched this one here to the bottom of the fraction. We just switched them. So if I have a negative exponent, all I need to do to make it positive is bring it to the bottom of the fraction. So my x's are already positive, so I will just leave them where they are in the top of the fraction. The y's, however, are negative, so in order to make them positive, I'll bring them to the bottom of the fraction, and now it's y to the power of positive 4. The z's are already positive, so I will leave them exactly where they are, z to the power of positive 2. Now that we have all positive exponents, this is your simplified expression. There is one more part to this negative exponent rule, and that is if we reverse it. So let's say from the start, your negative exponent is in the bottom of the fraction. If we have 1 divided by a to the power of negative n, that would equal a to the power of positive n. So if we have, for example, 1 divided by x to the power of negative 5, we could rewrite this as x to the power of positive 5. So let me explain why this works. So we have 1 divided by x to the power of negative 5. Something that we just learned is that this x to the power of negative 5 can be rewritten as 1 divided by x to the power of 5. So technically I have 1 divided by x to the power of 5. So when I'm dividing fractions, I can rewrite it like this. 1 divided by x to the power of 5. And when I'm dividing fractions, remember, here I'll make this into a fraction, so I'm truly dividing fractions here. We keep the first one the same, change it to multiplication, and then flip to the reciprocal of the second fraction. So 1 times x to the power of 5 is x to the power of 5. 1 times 1 is 1. And anything divided by 1 is just that itself. So this would equal x to the power of 5. So that is why we can change this expression here, 1 divided by x to the power of negative 5, to be just x to the power of 5. Okay, so here are a couple more examples of this rule. So first we have r to the power of 4 divided by t to the power of negative 2. So what we can do is, this is similar to the trick I was saying before, where if you have a negative exponent on the top of the fraction, to make it a positive exponent, you bring it down to the bottom. Well, the same is true in reverse. If you have a negative exponent on the bottom of your fraction, you can make it positive by bringing it to the top. Because remember, if you are dividing by a negative exponent, this equals just a whole number positive version of that exponent. Or in other words, we can make this a fraction by putting a 1 on the bottom. So we are taking this on the bottom of the fraction and bringing it to the top of the fraction and making it positive. So if I have r to the power of 4 divided by t to the power of negative 2, I can make this t exponent positive by bringing it to the top of the fraction. So we have r to the power of 4 times t to the power of positive 2 over 1. There's nothing left on the bottom. We canceled it out. And we don't really need that 1 on the bottom, so this would just equal r to the power of 4 times t to the power of 2. Let's look at another example. So x to the power of 6 times y to the power of 2 divided by y to the power of negative 1 times z to the power of 4. So remember, if you have positive exponents, it's simplified. But if you have a negative exponent, it's not simplified. You need to take it to the other side of the fraction. So going through each variable here, the x to the power of 6 is already positive, so we'll leave it where it is. Same with this y to the power of 2. The numerator is already all positive, so we don't have to move anything. The y in the bottom here, however, y to the power of negative 1, that's negative. So in order to make it positive, we just need to bring it up to the top of the fraction to make it y to the power of 1. And then the z's are already positive, z to the power of 4. So all we did is we made this y positive by bringing it up to the top of the fraction. Now the last step is we'll see if we can combine anything to simplify this even more. Well, I'm noticing we have two exponents that we're multiplying with the same base of y, so we can combine them. Here we have two y's we're multiplying. Here we have one y that we're multiplying. So all together we have 3 y's that we're multiplying. Nothing else can combine, so we'll just leave it how it is. And this is the most simplified version of this original expression. All right, here's a couple more examples. So when we have, remember, a negative exponent, in order to make it positive, we bring it to the other side of the fraction. So if we have p to the power of negative 8 divided by p to the power of 3, I want to make this negative 8 positive, so I bring this down to the bottom of the fraction. P to the power of 3 times p to the power of 8. Well, I have nothing left in the top. So what we do is we put a 1 there on top, because technically what we're doing is we are dividing these p's, and so they cancel, and when we divide something by itself, it equals 1. So that's why we have a 1 up on top. Then we can further combine and simplify this expression by combining the p's in the denominator. We have 3 p's and 8 p's that we're multiplying, so in total, we are multiplying 11 p's altogether. So here is your simplified version of this expression. Next one, p to the power of -4 divided by p to the power of -5. In order to make these exponents positive, I need to bring this p to the power of 4 down, -4, I need to bring it down to the bottom. The p to the power of -5, I bring it to the other side as well, up to the top. So I would have p to the power of +5 divided by p to the power of +4. We just switched the sides and the exponents became positive. Then we can finally simplify this even more by, we have 2 exponents that we're dividing with the same base, so we can combine them. Remember, when we divide exponents, in order to simplify them, we subtract the exponents. So 5 minus 4 is 1, so this would equal p to the power of 1. We don't really need that 1, remember it can be an invisible 1, so this could just be p as your final answer. Here are 3 more examples, so my recommendation is to pause the video, try to work them out yourself, and once you have the answers that you think are correct, play the video again to check them and see how you did. Alright, so these are the answers that you should have gotten. Go ahead and check them. If they look good, you understand it, go ahead and work on the homework practice for today, and you can stop the video now. If you got something wrong or you want further explanation, I'm going to go ahead now and explain how I got all of these answers. So starting off with the first one, I have a few negative exponents here. So my negative exponents, in order to simplify them and make them positive, I need to bring them to the other side of the fraction. And the positive exponents, the ones that are already positive, will stay exactly where they are. So the a, it's already positive, I'll leave it on the top. B to the power of -2, I bring it to the bottom to make it positive. C to the power of -3, I bring that to the bottom as well to make it positive. All right, now I will go down to these. A to the power of -4, to make it positive, I will bring it to the top. Now it's a to the power +4. And then b to the power of 3 and c to the power of 4 are already positive, so I'll leave them exactly where they are. Then my next step is to combine any exponents that have the same base to simplify it even more. So on the top we have a times a to the power of 4. Remember, this a has an invisible 1 here. So I have altogether 5 a's that I'm multiplying, divided by, I can combine my b's. Altogether we have 2 and 3, so in total 5 b's that we are multiplying. And then I can also combine the c's. We have 3 c's and 4 c's that we're multiplying, for a total of 7 c's that we are multiplying. So that is where I got this answer from. Okay, then next problem. Again, I'm going to try to simplify my negative exponents, but first, before I do that, in order of operations, after parentheses comes exponents. So I need to cancel out this exponent first by applying it to everything inside this set of parentheses. So that would be 6 to the power of 2 times a to the power of -1 to the power of 2 times b to the power of 2 divided by, and then I'll just keep the bottom the same for right now. Now I will simplify this. 6 to the power of 2, 6 times 6 is 36. a to the power of -1 to the power of 2. When I have an exponent raised to another exponent, I multiply them together. -1 times +2 is -2, and then we just have b to the power of 2. In the bottom of our fraction, we have b to the power of 2 to the power of 4, so I will multiply these together to get b to the power of 8. Next, we are going to simplify this by getting rid of any negative exponents. So this a to the power of -2, I'm going to need to bring this down to the bottom of our fraction to make it positive. So then this would turn into 36 times b to the power of 2 divided by a to the power of 2 times b to the power of 8. Okay, next I'm going to try to simplify it even more by combining exponents that have the same base. We have 2 exponents with a base of b, so I can combine them. We have b to the power of 2 divided by b to the power of 8. So remember, when we divide exponents that have the same base, we subtract the exponents. So I'm going to do 2 minus 8, and 2 minus 8 equals -6. So this would then become 36 times b to the power of -6 divided by a to the power of 2. And then very end, now we're back to having negative exponents. So in order to totally simplify it, we need to make this b to the power of -6 positive by bringing it down to the bottom of the fraction, and that is where I got this answer from. Okay, last up, I will show you how I did this last example here. So first off, we are going to apply this exponent of -3 to everything inside the parentheses. And then the bottom will stay the same. Then, before I do anything else, I'm noticing that all of these have negative exponents. So I know right away that in order to make it positive, I'm going to need to bring all of these down to the bottom of the fraction. So I'm going to do that first. And also this m to the power of -6, to make it positive, I'll need to bring that to the top of the fraction. So now the m to the power of -6 becomes positive. Then the 4 and the n to the power of 4 were already positive, so I leave them. And then I will keep everything. Now I'll have the others, but now they are all positive because I switched the side of the fraction. All right, so we can simplify this further. So we would have m to the power of 6 divided by 4 times n to the power of 4, -2 to the power of 3. This is -2 times -2 times -2. So -2 times -2 is +4. +4 times -2 is -8. M to the power of 3, n to the power of 2 to the power of 3. I multiply them to get n to the power of 6. My next step is going to be to combine anything that is in common. So we have 2 just straight up numbers here, a 4 and a -8. So we can multiply them. 4 times -8 is -32. That's where this came from. The n's we can also combine. N to the power of 4 times n to the power of 6. We have 10 total n's that we are multiplying. And then the m's we can also combine. We have 6 m's divided by 3 m's. So I subtract and get a total of 3 m's left. So that is where the m to the power of 3 came from.